The mathematical principles of natural philosophy definitions. Definition 1. The quantity of matter is a measure of the same arising jointly from the density and magnitude. Volume. Air with the density doubled, in volume also doubled, shall be quadrupled, in triple of the volume, 6 times as great. You understand the same about snow and powders with the condensing from melting or by compression. And the account of all bodies is the same, which are condensed in different ways by whatever causes. Here meanwhile I have no account of a medium, if which there were, freely pervading the interstitia of the parts of the body. But I understand this quantity everywhere in what follows under the name of the body or of the mass. That becomes known through the weight of any body, for the proportion to the weight is to be found through experiments with the most accurate of pendulums set up, as will be shown later. Definition 2. The quantity of motion is a measure of the same arising from the velocity and quantity of matter jointly. The whole motion is the sum of the motions within the single parts, and therefore in a body twice as great, with equal velocity, it is doubled, and with the velocity doubled 4 times as great. Definition 3. The innate force of matter is the resisting force, by which each individual body, however great it is in itself, persists in its state either of rest or of moving uniformly straight forwards. This innate, or vis insita, force is proportional always to its body, and nor does it differ at all from the inertia of the mass, unless in the required manner of being considered. From the inertia of matter it arises, that each body may be disturbed with difficulty, either from its state of rest or from its state of motion, from which the vis insita will be possible also to be called by a most significant name, the vis inertia, force of inertia. Truly the body exercises this force only in the change made of its state by some other force impressed on itself, and the exercise is under that difference with respect to resistance and impotence, resistance, inasmuch as the body is resisting a change in its state by the force acting, impotence, inasmuch as the same body, with the force of resistance requiring to concede to the obstacle, tries to change the state of this obstacle. One commonly attributes resistance to states of rest and impetus to states of movement, but motion and rest, as they are considered commonly, are distinguished only in turn from each other, nor are bodies truly at rest which may be regarded commonly as being in a state of rest. Definition 4. The impressed force is the action exercised on the body to changing the state either of rest or of motion uniform in direction. This force is in position only during the action, nor remains in the body after the action, for the body may persevere in any new state by the force of inertia only. Moreover, the impressed force is of diverse origins, as from a blow, from pressure, or from the centripetal force. Definition 5. It is the centripetal force, by which bodies are drawn, impelled, or tend in some manner from all sides towards some point, as towards the center. Gravity is a force of this kind, by which bodies tend towards the center of the earth. The magnetic force, by which iron seeks a lodestone, and that force, whatever it may be, by which the planets are drawn perpetually from rectilinear motion, and are forced to revolve along curved lines. A stone rotating in a sling is trying to depart from the turning hand, and in its attempt has stretched the sling, and with that the more the faster it revolves, and it flies off as soon as it is released. I call the force contrary to that endeavor the centripetal force, by which the sling continually pulls the stone back to the hand and keeps it in orbit, as it is directed to the hand, or the center of the orbit. And the account is the same of all bodies, which are driven in a circle. All these are trying to recede from the center of the orbit, and unless some other force shall be present trying the opposite to this, by which they may be confined and retained in the orbits, and each thus I call centripetal, they will depart with a uniform motion in straight lines. A projectile, if it were abandoned by the force of gravity, would not be deflected towards the earth, but would go in a straight line to the heavens, and that with a uniform motion, but only if the air resistance may be removed. By its gravity it is drawn from the rectilinear course and always is deflected to the earth, and that more or less for its gravity and with the velocity of the motion, so that the smaller were the gravity for a quantity of matter, or the greater the velocity with which it was projected, by that the less will it deviate from a rectilinear course, and the further it will go on. If a leaden sphere is projected from the peak of some mountain with a given velocity along a horizontal line by the force of gunpowder, it may go on in a curved line for a distance of 2 miles, before it falls to earth. Since here with the velocity doubled, it may go on twice as far as it were, and with 10 times the velocity 10 times as far as it were, but only if the resistance of the air is removed, and by increasing the velocity, it may be possible to increase the distance to any desired distance in which it is projected, and the curvature of the line that it may describe be lessened, thus so that it may fall only according to a distance of 10 or 30 or 90 degrees, or also so that it may encircle the whole earth or finally depart into the heavens, and from the departing speed to go on indefinitely, and by the same account, by which the projectile may be turned by the force of gravity in obit, and may be able to encircle the whole earth, also the moon is able, either by the force of gravity, but only it shall be of gravity, or some other force, by which it may be acted on, always to be drawn back from a rectilinear course towards the earth, and to be turning in its orbit, and without such a force the moon would not be able to be retained in its orbit. This force, if it should be just a little less, would not be enough to turn the moon from a rectilinear course. If just a little greater, would turn the moon more, and it would be led from its orbit towards the earth. Certainly it is required that it shall be of a just magnitude, and it is required of mathematicians to find the force by which a body will be able to be retained carefully in some given orbit, and in turn to find the curved path in which a body departing from some given place with a given velocity may be deflected by a given force. Moreover, the magnitude of this centripetal force is of 3 kinds: absolute, accelerative, and motive. Definition 6. The absolute magnitude of a centripetal force is a measure of the same, greater or less, for the effectiveness of the cause of propagating that from the center into the orbital regions, so that the magnetic force for the size of the lodestone either extends more in one lodestone of greater strength, or lesser in another. Definition 7. The accelerative magnitude of the centripetal force is the measure of this proportional to velocity that it generates in a given time, as the strength of the same lodestone is greater in a smaller distance, smaller and greater, or the force of gravity is greater in valleys, less at the tops of high mountains, and small still, as it will become apparent afterwards, at greater distances from the globe of the earth, but at equal distances it is the same on all sides, because therefore all falling bodies, heavy or light, large or small, with the air resistance removed, accelerate equally. Definition 8. The motive magnitude of the centripetal force is the measure of this, proportional to the motion, which it generates in a given time, as the weight is greater in a greater body, less in a smaller, and in the same body greater near the earth, less in the heavens. This magnitude is the centripetency or the propensity of the whole body to move towards the center, and, as thus I have said, the weight, and it becomes known always by that force equal and opposite to itself, by which the descent of the body can be impeded, and the magnitudes of these forces for the sake of brevity can be called the motive, accelerative, and absolute forces, and for the sake of being distinct refer to bodies attracted towards the center, to the locations of these moving bodies, and to the center of the forces. There is no doubt that the motive force for a body, as the attempt of the whole towards the center of the attracting body is composed from the attempts of all the parts, and the accelerative force at the position of the body has a certain effectiveness, spread out in the orbit from the center through the individual locations to the bodies towards moving the bodies which are in these places, but the absolute force towards the center, as being provided by some cause, without which the motive forces may not be propagated through the regions in the revolution, or for that cause there shall be some central body, such as the lodestone at the center of the magnetic force, or the earth from the center of the force of gravity, or some other cause which may not be apparent. The concept here is only mathematical, for I do not consider the causes and physical seats of the forces. Therefore the accelerative force is to the motive force as the velocity is to the motion. For the quantity of the motion arises from the velocity, and also from the quantity of matter. The motive force arises from the accelerative force taken jointly with the same quantity of matter. For the sum of the actions of the accelerative force on the individual particles of the body is the whole motive force, i.e. the weight, from which next to the surface of the earth, where the accelerative gravity or the gravitating force is the same in all bodies, the motive gravity or weight is as the body, but if it may ascend to regions where the accelerative weight shall be less, the weight equally may be diminished, and it will be always as the body and accelerative gravity jointly. Thus in regions where the accelerative gravity is twice as small, the weight of the body small by 2 or 3 times will be 4 or 6 times as small. Again I name attraction and impulses, in the same sense, accelerative and motive forces, but for these words attraction, impulse, or of any propensity towards the center, I use indifferently and interchangeably among themselves. These forces are required only to be considered from the mathematical point of view and not physically, from which the reader may be warned, lest by words of this kind he may think me to define somewhere either a kind or manner of action or a physical account, or to attribute truly real forces to the centers, which are mathematical points, if perhaps I have said to draw from the center or to be forces of the centers. Axioms, or the laws of motion. Law 1. Every body perseveres either in a state of resting or of moving uniformly in a direction, unless that is compelled to change its state by impressed forces. Projectiles persevere in their motion, unless inasmuch as they may be retarded by the resistance of the air, and they are impelled downwards by the force of gravity. A child's spinning top, the parts of which by requiring to stick together always withdraw themselves from circular motion, does not stop rotating, unless perhaps it may be slowed down by the air. But the greater bodies of the planets and comets preserve both their progressive and circular motions for a long time made in spaces with less resistance. Law 2. The change of motion is proportional to the magnitude of the impressed motive force, and to be made along the right line by which that force is impressed. If a force may generate some motion, twice the force will double it, 3 times triples, if it were impressed either once at the same time, or successively and gradually, and this motion, because it is determined always in the same direction generated by the same force, if the body were moving before, either is added to the motion of it in the same direction, or in the contrary direction is taken away, or the oblique is added to the oblique, and wherefrom that each successive determination is composed. Law 3. To an action there is always an equal and contrary reaction, or the actions of two bodies between themselves are always mutually equal and directed in opposite directions. Anything pressing or pulling another, by that is press or pull just as much. If anyone presses a stone with a finger, the finger of this person is pressed by the stone. If a horse pulls a stone tied to a rope, and also the horse, as thus I may say, is drawn back equally by the stone, for the rope stretched the same on both sides requiring itself to be loosened will draw upon the horse towards the stone, and the stone towards the horse, and it may impede the progress of the one as much as it advances the progress of the other. If some body striking another body will have changed the latter's motion in some manner by the former's force, the same change too will be undergone in turn on its own motion in the contrary direction by the force of the other, on account of the mutual pressing together. By these actions equal changes are made, not of the velocities but of the motions, obviously in bodies not impeded otherwise, for changes of the velocity are made likewise in the contrary parts, because the motions are changed equally, they are inversely proportional with the bodies, i.e. with their masses. This law is obtained with attractions also, as will be approved in the nearby scholium. From definition 2 we have, motion equals mass times velocity equals m. V. From law 2 we have, force equals change in motion therefore, force equals change in motion equals delta. M. V. Equals dm. V. dt. For constant mass, force equals m. dv. dt. Equals m. A. Using the product rule we have, force equals dm. V. dt. Equals m. dv. dt. Plus v. dm. dt. Let us examine a problem which illustrates the use of Newton's 3 laws. 53. Firefighters spray water horizontally at the rate of 41 kilograms per second from a nozzle mounted on a 12,000 kilogram fire truck. The water speed is 28 meters per second relative to the truck. A. Neglecting friction. What is the initial acceleration of the truck? B. If the 12,000 kilogram truck mass includes 2,400 kilograms of water, how fast will the truck be moving when the water is exhausted? Taken from Richard Wolfson and J.M. Pasakoff, Physics 3rd edition for Scientists and Engineers, Chapter 10, page 260, Problem 53. By Newton's first law we see, since a force has been impressed, that there will be a change in the fire truck's relative state. By Newton's second law we know that force will be equal to the change in motion, F equals m. dv. dt. Plus v. dm. dt. By Newton's third law we know that the change in motion of the water will be opposite that of the fire truck. Therefore, the change of the motion of the fire truck will be equal in magnitude the change of motion of the water, but in the opposite direction, or m. dv. dt. Equals negative v. dm. dt. Now it's just simple math.